or m2 minus m1, that will become 0. So in that case, what will become? This V2 will become equal to suppose it is m. So suppose it is m. Then here will become twice m by 2m. So it will be cancelled. So V2 will become equal to U1. And this V1 will become equal to U2. That is, the two objects will interchange their velocity. The first object will start moving with velocity of second one, and second object will start moving with velocity first one. Two objects will interchange their velocity. That is, if first is moving with 10 meter per second, second was moving with 2 meter per second, then after collision, the first will become 2 meter per second and second will start moving with 10 meter per second. Provided the collision is elastic and the two objects has got same mass. Now this, if U2 is 0, if velocity of second object is 0, what will be? If U2 becomes 0, then what will become? And this mass is same. Then this V2 will become equal to U1 and V1 will become 0. That is, after collision, first object will come to the position of rest and second will start moving with whatever the velocity of first object was there. So suppose this is the velocity by moving with velocity U or U1. The second ball is, both are m only, mass is same. This is 0. Then after collision, what will be? This first ball will start moving with velocity. The first ball will come stationary, and then second will start moving with velocity U1. So after collision, what will be? The first one will remain stationary, and only second ball will start moving with velocity U1. This sometimes is asked. So many balls are there in the position of, identical balls are there. They are kept in this way. All are identical, same mass. Now, if one ball which is moving with velocity u strikes it, what will happen? This ball will become stationary and this will start moving with velocity u, if the collision is elastic. So when it strikes, whatever momentum is, all will be transferred to this one. This will transfer to this. This ball will transfer to third one. This one fourth one. This one fifth one. So finally, this ball will start moving with velocity u, and this one will come stationary. If it is elastic collision, this will be the situation. So in case of elastic collision, we will use two things. One will be, while solving the numerical, we will use momentum is conserved and velocity of separation is equal to velocity of approach. For inelastic collision, only one, that is momentum is conserved. Now, for inelastic collision, what will be? So, which two relation we will write? So, in this case, well, this is m1 moving with velocity u1, another one is m2 moving with velocity u2, so they collide with each other here, and after collision, its velocity is v1 and v2. Then, what are the two relations which we have to consider? One relation will be this m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. That will be the one relation. And second relation you will use this v2 minus v1 is e times u1 minus u. So these are the two relations by which we will solve the problems. The coefficient of restitution will be given. If only one variable is there, one thing is unknown, only one relation will be used. If two variables are there, then this relation will also come. So that will depend on what is asked. For perfectly inelastic, what is the relation? In that case, V2 and V1 will be equal. In that case, this V2 and V1 will be same. Say this is V. Still the same problem, or what is visible or not?
Sometimes clear, sometimes blur.
Yes, sir. Sometimes.
Okay. So in that case, what will become? Only we will apply the law of conservation of linear momentum. In this case, this E will become 0. E 0 means V2 minus V1 will be 0. So V2 will be equal to V1. So relation will become this M1 U1 plus M2 U2 will be equal to M1 plus M2 V. Now, sometime you will be asked what will be the loss in kinetic energy, or sometime fractional loss in kinetic energy. That will be asked. Fractional loss in kinetic energy. Generally, in case of inelastic collision or perfectly inelastic collision. In case of elastic collision, there is no loss. Kinetic energy is conserved. But in case of inelastic or perfectly inelastic, you will be asked what is the loss in kinetic energy. So fractional loss in kinetic energy. During so what part is lost? 1/3, 1/4, 1/6, or 10%, 20%? Either it will be fractional loss or you may be asked percentage loss. So what is the fractional loss? What will be the percentage loss? That you will be asked to find. So what is initial kinetic energy? So loss in kinetic energy. Initial kinetic energy minus final kinetic energy of system. So initial kinetic energy, what was that? Half M1 U1 square plus half M2 U2 square minus half M1 plus M2 V square. So this is the loss. Fractional loss means loss by original kinetic energy. So fractional loss. Loss in kinetic energy by original kinetic energy. So we'll find this delta E, suppose. So this is delta E over original means half m1 u1 square plus half m2 u2 square. If you are asked percentage loss by original into 100, so that will come percentage loss. So these are the important formulas, or these are the important things which we have to keep in mind while solving the numericals. Mainly numericals will be asked. Only one derivation, that is derivation of velocity after collision. Now suppose you are asked, find the fractional loss in kinetic energy when an object of mass m moving with velocity u collide with another object of mass n times. Collide with stationary object. Okay. Another stationary object of mass n times. Assume the collision to be perfectly inelastic. Okay. Suppose the collision is perfectly inelastic. So what is happening in this case? Suppose this is the ball of mass m moving with velocity u. It is colliding with another ball which is mass n times m. And this is g. So u1 is u and it is stationary object. As the collision is perfectly inelastic, so both the ball are moving with same velocity, maybe v. So one relation will be law of conservation of linear momentum. So what we'll get? Mu plus 0 will be equal to M plus N into M V. So we got this V will be 1 by 1 plus N or N plus 1, whatever you will say. Now, what is initial kinetic energy? Half mu square. Final kinetic energy? Half m plus n m v square. Half m 1 plus n, and in place of v will write u square by 1 plus n whole square. So what is the loss in kinetic energy? So fractional loss in kinetic energy, loss by original. So loss is half mu square minus, here what will become? Half mu square, you can take common and 1 will be cancelled. It is n plus 1 or 1 plus n, what can you write? By half mu square. Half mu square common, it will be cancelled. So how much will be left? 1 minus 1 by n plus 1. N plus 1 minus 1, that is n by n plus 1. So this will be the fractional loss in kinetic energy. So this part, if suppose it is 3 times, the ball which is colliding with the stationary ball and the mass of the stationary ball is 3 times, then it will become 3 by 4. So 75% of the energy will be lost. Only 25% energy will be with the system. 75% energy will be transformed into some other form. Okay, so in this chapter you have to do, you have this much only, and you are expert in solving the numericals, so you might have solved all the numericals. Anyone having any doubt? You ask next day. Otherwise, we will start new chapter. So solve the numericals. 50 or 56 numericals are there. Work power energy you have already completed, I think. Only collision part is left. So today you finish. Next day you ask your doubts. Is it audible or not?
Yes.
Yes, sir.
Audible? Huh?
Yes.
Yes, sir.
Listening everything, no?
Yes, sir.
But not